Hello everyone, welcome back to JDCodebase. Today we are solving a very interesting array problem, that is the LeetCode number 724, find pivot index. In this problem, we need to find an index where the sum of element strictly to the left of the index is equal to the sum of all the numbers strictly to the index right. So sounds simple, but the thinking behind it is very powerful. First, we will clearly understand what strictly means here, and then we will solve it using the brute force approach step by step. And finally, we will understand how this problem connect the prefix sum and how we can optimize it. So if you really want to strengthen your DSA fundamentals, this problem is very important. So watch it. And so let's start with the reading this statement. So we are given an array of integer nums, okay, and we have to calculate the pivot index of this array. Now what is pivot index? This pivot index is the index where the sum of all numbers strictly to the left of the index is equal to the strictly to the sum of all the numbers to the index right. So if the index is on the left edge of the array, then the left sum is 0 because there are no element to the left, and this also applies to the right edge of the array, and we have to return the leftmost pivot index. If no such index exists, return -1. And we are given as some three examples, nums 1, 7, 3, 6, 5, 6, and the pivot index is the 3. So let's see in this. Now we have an array here 1, 7, 3, 6, 5, 6. So pivot index here according to the this statement is that the index where where the left sum and the right sum both are equal. Like here, if we calculate the left sum, 1 plus 7 8, 7 plus 3 11, and here if we calculate 5 plus 6 11, and the pivot index comes here is the 6, means this third index, this 3. So here basically strictly means we do not have to include this 3 third index, means if we see here, total sum is the of the means left sum, right sum, and nums of I. This one is the separate, always separate from the array. We have to calculate left sum, right sum, and we have to give the nums of means ith index this value. So for that, first we will see with the brute force solution. For that, let's start. For let I equal to 0, I is smaller than nums dot length I plus plus. Okay, we start a for loop, and here first left sum equal to 0, let right sum equal to 0, and first calculate the left sum till the means we start from the 0th index, from 0 to this index, means 5th index. Then first we have to calculate the left sum at every time, then we have to calculate the right sum. Means like here we have 0 to 1 index, then this is the left sum, 1 and 7, this is the right sum, the 6 5 6 is the right sum, and this is the pivot index if they are equal. Then this means we have to break down this 1 7 3 6 5 6, right sum, left sum. In the next step, 1 7 6 5 6, left sum, right sum. If they are equal, then this is the pivot index. Then 1 7 3 6 5 6, right sum, left sum, and this is the pivot index. 1 7 3 6 5 and 6, left sum and right sum. This is the pivot index. Means every time we have to calculate the left sum and we have to calculate the right sum. If they are equal, we have to return that index. So let's start a for loop that calculate the left sum, and it starts from the let j equal to 0 to j is smaller than I till the ith index, and j plus plus means we are not including I in this left sum, and left sum is the nums of I. Now it's time to calculate the right sum. Right sum start from the I plus 1. Still we are not including the ith index in this. J is smaller than nums dot length and j plus plus, and here right sum equal to nums of I, and we have to check whether left sum equal to right sum or not. If they are equal, just return the I, else again check in the last. If there is no exist in this, then return the -1. Let's run this solution. What happened to this? We are calculating okay, I have to write here j, not the I. So this means I have to we are in this for loop, and this for loop the index is the j, not the ith index. So yes, it's accepted. Let's try to submit the solution. Yes, it accepted. All the 747 test cases are passed. But if you see, this is not an optimized solution. We are this is a outer loop. It runs till the 0 to and nums dot length nums dot length means array index means array length. Then inside this for loop, we are again run the 2 for loop, and these run again till the n length of the array. So this is not an optimized version, because the time complexity here is the big of n square, because we are calculating left sum and right sum every time, and space complexity is the big of 1. There is no issue with that, but time complexity here is the big of n square. So we have to optimize that time complexity. For that we have to use the, let's say here there are some hint given topics, and hint is that create an array sum left where sum of left of I is the sum of all the number. You can use these hints. This one is also optimize this. So let me optimize this first, not the reset. So now if you see here, where is the, if we see here, total sum of the array is equal to left sum and right sum and plus nums of I. So my idea is that first we calculate the total sum as a prefix sum array, means not an array, just a total sum. Then we calculate each time and the right sum by just right sum comes here and total sum comes here, means left sum plus nums of I, and it's minus the total sum, or you can reverse that. So basically that the means we calculate the right sum from this, means total sum minus left of sum and nums of I. Then we calculate the check the left sum is equal to right sum or not. If not, we can add the left sum into this. Let me write here the code, then you will understand it clearly. First make a total sum equal to 0, and for let num of nums array, and we add the value here total sum in this, means we get the total sum of this array means 1 plus 7 plus 3 plus 6 plus 5 plus 6, means this is the 28. 11 plus 11 22 plus 6 is the 28. Okay, no issue with that. Now let's initialize a left sum with the value 0 initially and start a for loop let I equal to 0, I is smaller than nums dot length I plus plus. Here my idea is that if we calculate the right sum here, right sum, how we calculate? Just total sum minus left sum minus nums of I. Simple. Means from this formula, this total sum is the left sum plus right sum plus nums of I. If we change into means take this left sum here, nums of I here, then we can get the right sum here, right sum, right? A simple mathematics rule. Then we calculate the right sum. We check if left sum equal to right sum or not. If they are equal, just return the I. Else means every time if they are not equal, then we add the value here nums of I in the left sum. And in last, if there is no match comes, then return the -1. So with that, right sum is calculated at instant point, means at every loop, at every iteration, and right sum also we add the left sum. We calculate the left sum also at every iteration, means we add first nums of 0, then nums of 1, then nums of 2, then nums of 3. We means we calculate every iteration, we calculate the left sum, we calculate the right sum, and we check it in this single iteration. So let's run this solution. What happened? Left sum is not okay, just a spelling mistake. Left sum, yes, now it's okay. So let's try to submit the solution, and yes, it passed all the 747 test cases. So in this problem, in this LeetCode problem, we see both the solution. First one is we calculate the left sum and right sum at every iteration, means complete for loop till that index means 0 to ith index and I plus 1 index to nums dot length, means complete array we add every time. Then we optimize and just run a single for loop, and means the time complexity here is the big of n, because n big of n here, big of n here, so dominant is the big of n, means there is no addition of that. And in this we calculate the left sum and right sum by just a prefix sum way, so that we solve the pivot index problem step by step. In this we first understand the brute force approach, calculate the left and right sum for every index, then compare them carefully. And if this explanation you understand the concept clearly, make sure to like the video, subscribe to JDCodebase, and share it with your friends who is learning, with someone who is learning DSA. Keep practicing, keep building. I will see you in the next video.